Greetings, ladies and gents, and welcome back. It's Mike Maths and Science Club. Today we'll be looking at question 2. That's on physics, especially it's actually in particular physics paper 1. So it's actually a question on Newton's laws. So that's what we are going to be focusing on today. So they say that crate P of mass 1.25 is a kg is connected to another crate Q of mass 2 kg by a light inextensible string. So what they are simply saying by that word inextensible string would be that string or rope, if you want to put it that way, it doesn't contribute anything to our system. So it doesn't have any mass. It's massless, in some other words. So it doesn't contribute anything. So whenever we are, let's say, considering, let's say, whenever we are considering the masses of our object, we must just know that the mass of that string would be almost zero. It's actually zero. So they say that the two crates are placed on a rough horizontal surface. A constant force F of magnitude 7.5 acting on at an angle Q to the horizontal is applied to crate Q as shown in the below. They say the crate accelerates at 0.12 meters squared per second squared to the right. So they said that crate P experiences a constant frictional force of 1.8 Newton, and crate Q experiences a constant frictional force of 2.2. Now I know it's a little bit, some students actually they often just skip that paragraph there, but it's very important for you to read it. Reason being, they often just hide most of the information that you would require in those paragraph. So I know it's a little bit annoying to read that whole essay, but unfortunately, yeah, there's nothing we can do. Right. So they said that state Newton's second law of motion in words. So we know that Newton's second law says that when a net force is applied to an object, the object will accelerate at an acceleration that is directly proportional to the net force and inversely proportional to the mass of the object, of the object. So that would be the formal definition of Newton's second law in words. So you need to know these definitions, as you can know that it is actually 2 marks. Of course, getting that 2 mark would be a good score there. You know that 2 mark would actually be a line between you getting a code 7 and a code 6. So it would be wise for you to know your definitions, so you can just start by maximizing those definitions, because they they occupy a lot of marks. So if you get all of those definitions, you would actually have a greater chance of getting a distinction at the end. So they said that draw a free body diagram for crate P. So if we look at crate P, we notice that of course we have the tension acting on that object. But what else do we know? They say that that box is actually pulled on on a rough horizontal surface. So since they say that that's a rough horizontal surface, so that would mean that there is also friction acting on that object, and so other force that would be acting on the object would be the normal force. We know that that force is always perpendicular, and would also have it is always perpendicular to our surface, and would also have the force of gravity. So if you were to draw the free body diagram of that object P, what would have a normal force, would have Fg, all right, and would have a tension there, and would have friction. Now of course you know that friction is always opposing the motion of our object, so that would be for 2.2. right? So for 2.3.1, 2.3.1. So they say that calculate the tension, the magnitude of the tension in the string. Now, remember that this tension is actually acting both on crate P and Q. So what you need to do in this case would be to work from the crate that has the most information. All right. So if you were to look at crate Q, we don't know the magnitude of the tension, right? Which is what we are looking for, but we also do not have the angle theta. All right. So in this case, we wouldn't be able to figure out the tension immediately. Why? Because we also have an unknown there, of an unknown variable of theta. Because if you were to draw a free body diagram of that crate, which is Q, what you would have there, you would have Fg, you would have tension, but you would also have friction, and you would have, now if you were to resolve that force, all right, F, what you would have, now remember we still have normal force there. So what you would have there, I'm just going to make that a little bit big. So what you would have there, you would also have F A perpendicular, all right, or F A Y if you want to put it that way. And you would also have F A parallel. So to find FA parallel, so you would say, so FA parallel would actually be equals to FA, all right, FA sine, actually it's cos. So it would be FA, force applied, multiplied by cos of theta. So that theta would actually be the angle, that angle there. So as you can note, we don't know the tension. We also do not have that theta there. So if you were to refer to that crate, which is P, what you would note is that we actually have more information on that crate. We have the frictional force, right? We don't know the tension, which is what we are looking for. But what else would we need? We also have the acceleration of that block. All right. So if we were to say that F net, let me just write that on that side. So if we always say that F net is equals to MA, all right. Now what you must note is that what am I writing now? Now what you must note is that acceleration is also a vector quantity. So when you are substituting acceleration, you must substitute it with its direction. So what we have there, now we know that of course F net would be the sum of all the forces that actually are acting on that particular dimension. So in this case, our crate is actually accelerating in that horizontal dimension. So what forces do we have in that dimension? We have friction, we have tension. All right, so those are the only forces that are acting on the horizontal dimension. So what we have, so what I'm gonna do, I'm just gonna choose going to the right is positive, and then of course going to the left is negative. So what I would have eventually would be T, which is tension, that would be positive, minus Fk. So that would actually be equals to MA. Now M, we know that's the mass, so we don't know T, which is what we are looking for. We know the kinetic friction acting on that block, which is P. They say that it is actually experiencing a constant frictional force of 1.8. So this would be it would be T minus 1.8, which is equals to the mass. So which would be 1.25. So of course the acceleration, they say that's 0.1, but not, we must also include the direction of that acceleration. So it would be negative 0, actually it's positive, so it would be plus 0.1. All right. Now, as you can note, we actually have one unknown there. So to find t, what I'm going to do, I'm just gonna transpose everything to the other side. So this would be 1.25. Let me just take my calculator. You can also, just take yours so that you can confirm if if I'm getting the right answers or I'm just getting my own values. So if you say 1.25 multiplied by 0.1 and you add 1.8, what you would get there would be tension being 1.925. Jeez, what am I doing? Oh, I actually have that button there. Actually, yeah, so that would be 925. So that would be 9. Jeez, what am I doing? Forgive me. So that would be dot 925 Newton. Now remember, they said that they want the magnitude. They are not actually concerned about the direction. So but if you note, we actually got that to be a positive value. Now that makes sense because we know that the tension on that block P, it is actually pulling it to the right. So as a result, we actually expected that to be positive. So that would be the answer for 2.3.1. So they said that calculate the angle theta. Now that's gonna be, it's not gonna be that tough. Reason being, we now have tension, right? If you were to focus on this a block that we have there, we now have tension. So what do we have? So if I were to say that F net is equals to MA, all right, how many forces that are acting on that on the horizontal plane on that crate Q? So what do I have? I actually have friction, I have tension, also I have force applied that is actually parallel to our surface. So we have tension. So I'm actually just gonna choose to the right again, being positive. So I have tension, all right, being positive, minus Fk plus, you see that would actually be minus. So my plus F A parallel. So that would actually equals to MA. Now what I'm gonna do, I'm just gonna erase this down here so that I have somewhere to write. So what do I have? I have tension. I found tension to be 1.925. So that's gonna be minus 1.925. All right. So minus F, so which is 2.2, plus force applied, which is actually 7.5. All right. So that would actually be sine. Actually, that was cos of theta. So that will actually be equals to 2 multiplied by 0.1. Sorry for squeezing that there. So what I'm going to do, I'm going to transpose what I have right here. Going to transpose that to the right, and I would only be left with 7.5 multiplied by that cos of theta. So what I would have 7.5 cos of theta being equals to 2 multiplied by 0.1 plus 1.925 plus 2.2. So what I'm going to do, I'm just going to divide by 7.5. So I would have cos of theta being equals to whatever value that's going to come there, divide that by, so that's going to actually be 2 multiplied by 0.1 plus 1.925 plus 2.2. You divide that by 7.5. So what you're going to get there would be Now you would need to keep all the decimals. So I'm just gonna keep it as a fraction. So it's 1 point, it's actually 173 divided by 300. So to get theta, I'm just gonna say shift cos. So what you're gonna have, you can have cos of, you can actually, I'm lying. I'm very much lying. So that would be theta would actually be equals to cos minus there. So that would be 173 divided by 300. So if you put that in your calculator, let me just punch that right now. So let's say shift cos. So you actually have 54 point, if theta is 54.783, 78 degrees. So that would be the value that you are going to get for that question there.